think that these were actually unexpected but important results that showed that the device itself has an objective effect on human physiology and on brain waves. You cannot be wise in advance. You should do the experiment using such and such stimulation regime and see what really are the effects, because they can be different from expectations. They should put it some 5 to 10 minutes even before going to meditate, so that this effect accumulates just before they go to meditations.
Hey everybody, welcome to Techforpsych, where we combine the latest neurotechnology with ancient wisdom to supercharge your brain. I'm Dr. Cody Rall, your medical doctor confidant. In my last video, we took a look at the mid-level TMS device called NeoRhythm that actually uses magnetic pulse waves in order to change your subjective state to become more alert or become more relaxed, or use it during meditation. We dived into the science behind it. We took a look at segments of my interview with Dr. Igor, Jerman, the head scientific mind behind the device. We took a look at his review papers of a randomized control trial that they did with the device. In this video, we're gonna do the full interview with Dr. Igor Jerman. I learned so much from him, just learning about his background, his Bion Institute that we'll talk about, the Bioelectromagnetics Institute of New Biology. We talked about the mechanism of action behind the device. We talked about the randomized control trials that he ran. We also touched on experiments that you can run at home using different device modalities like EEG, using the Muse headband, or other neuro wearables in order to investigate its effects on your own mind. So stick around. Dr. Igor Jerman, thanks so much for joining me here on Techforpsych. It's really nice to have you on.
Yeah, thank you too for inviting me to this interview.
And I'd have to say your line of work is completely fascinating to me. I've read some of your bio, and the company that you've formed called Bioelectrics and New Biology in Slovenia. And your work seems to be in that interface between very minute biological influences and the influence of magnetic fields and other influences. And I wanted to ask you how you actually got into that line of work, and how over time that actually developed into Bion and this wonderful device that we can actually use now called NeoRhythm.
Yes. So our institute was founded in 1990. So it's now 30 years old. And it was founded as the Institute for Bioelectromagnetics and New Biology. And because even at that time, we saw that life cannot be explained only by means of, let's say, biochemistry and chemical reactions, but that it exists also on the level of electromagnetic field, or let's say on the field level. So we began to study the fields, and of course it is not a gravitational field or weak field or so on, but it is actually an electromagnetic field. We knew the theory of Fröhlich about the coherent states of the electromagnetic field in the cell that is somewhat produced by oscillating dipolar molecules in the cells, so that at least partially all organisms, not only humans, but also bacteria and plants and animals, have this partially coherent field. Coherent means that its oscillations are all in phase, like with a laser, yeah? So that all these oscillations are either up or down, at the same time, which gives a very high penetrating power for this field, and also that it can have enormous informational capacities. We were interested with this aspect of organisms that is mostly neglected by contemporary biomedical sciences, and we began studying theoretically and also empirically, let's say, bioelectromagnetics, which we can divide into two parts. One part of bioelectromagnetic science concerns itself with, let's say, exposure of organisms to external electromagnetic field stimulation. It can be only magnetic field or only electrical static field. This is one extreme, and on the other extreme we can have even light, like very, very fast oscillating electromagnetic field. And but I may say all this concerns the non-ionizing radiation. So this is bioelectromagnetics. Is not a science about radiating electromagnetic fields like X-rays or even ultraviolet rays, but let's say light waves and below in the frequency range, like infrared, microwaves, and so on. So mostly we studied the effects of extremely low frequency fields on organisms, and not so much actually on humans. This on humans was just involving NeoRhythm, and I will come to this later. But we began with plants mostly, because such systems were more controllable, like animals, for instance. So we found that at certain frequencies we can stimulate plants more, their growth, development, and so on, or even the germination of seeds. And this is all published in scientific articles. But this is, you know, still in the previous century, from the previous century. So this is one part, as I told you, of bioelectromagnetics. So the study of effects of electromagnetic stimulation on organisms. Now, the other part concerns actually the study, theoretical and experimental, of the endogenous field. So let's say our own bioelectromagnetic field. That is a very important part of our organizational capacities, or organizational capacities of our bodies to steer countless biochemical reactions. This is one of the theories, of course, here. And so we tried to connect these two areas of research and of thinking together, so that we think that by applying electromagnetic stimulation to organisms means, in the first place, that we expose their own endogenous electromagnetic field to this stimulation. And this is also shown in, let's say, stimulation of our brain, you know, because our brain, okay, when we apply high intensive repetitive transcranial magnetic stimulation, rTMS, to our brain, we know that it can provoke this depolarization of neurons, this mean action potentials. This means also that such high level, let's say at least 1 Tesla or even more, you know, intensive magnetic field can be invasive. And by this, it can also be, may have harmful side effects. It was even recognized, you know, in certain experiments that such stimulation can provoke seizures. Mm-hmm. So we try to find something that is not so forceful, not so invasive or aggressive. So something that does not provoke harmful side effects, that by this can be, let's say, less effective, but maybe safety is more important. So we try to find something that is perhaps less effective than high-intensive repetitive transcranial magnetic stimulation, but at the same time not harmful, because organism with low-intensity transcranial stimulation can still find its own, let's say, homeostasis. So it can repel such stimulation if it is not harmless for it, and so it is not forced into certain states. So this was, let's say, our most important thinking, why we try to find such low-level sort.
And Dr.
Okay,
German,
yeah.
And I think that for people that look at transmagnetic stimulation for depression that has been FDA approved in America since 2008, they can see that people are sitting in a chair. There is a magnetic wave that is released from the machine that causes a depolarization of the neurons in the scalp that stimulates certain areas of the brain. And this can be shown on brain scans that it is being activated. And there's a lot of evidence for it. But I wanted to ask you what you're talking about in terms of homeostasis of biological tissue. And then also perhaps what NeoRhythm is doing is more subtle. These are magnetic fields that are difficult to detect because they are, as you said, low intensity and having subtle effects on the biology. Why do you think this is an area of science that's been neglected until now in the scientific community?
Well, I think that this area of low-level electromagnetic effects on organisms, so low intensity level, is neglected because in physical terms, such fields should have certain power to work on ions in our organisms, or on certain, let's say, chemical reactions and so on. So because together the conventional biomedical science is very biochemistry oriented. So it sees organisms almost only in terms of molecular interactions and biochemistry. So it does not look at the biophysical level of organisms, where there is much to learn, I think, and much to explore. And I think that this is the most important reason. It also neglects, maybe because it is not easy to understand, let's say, quantum field theory that was developed by certain Italian physicists like Emilio del Giudice, Preparata Vitiello, that actually defined molecules and even the state of our liquid, within cells or among cells, in terms of these coherent domains that I spoke about. So that there is a coherent state of our cells, so there are so-called coherent domains, let's say, of different sizes, that can have an important effect on our physiology, on the working of our organisms, also on our level of biochemistry. So how different reactions are coordinated in our bodies. But all this is somewhat neglected because the main theory still maintains that all our biochemical reactions, or the majority of them, are actually orchestrated by Brownian movement. So by just random movements of molecules, it's their random dance. While this more advanced biophysical theory advocates the outlook that at least a part of these chemical reactions are really orchestrated by non-random electromagnetic oscillations, and that certain chemical reactions can be even, let's say, coordinated by long-range coherent modes, of these oscillations, of this organized electromagnetic, endogenous electromagnetic field in organisms.
Yeah, the two things that come to my mind that I've heard, like two processes that have been attempted to be explained with using these phenomena, were photosynthesis in plants. And also navigation of birds using magnetic fields.
Yeah.
No one could figure out how that was done before. And then there was some kind of structure in the eye that they felt like was using some kind of quantum biology effects. Are there other examples that you tend to use in discussion of these properties that elucidate how they actually work in your research?
Do you think research of bioelectromagnetics or research of coherent? There are researches that really indicate with high probability, let's say, that evaluates these theories of coherent oscillations. These oscillations or radiations were even measured and detected by the Czech group in Prague, led by Professor Pokorny, for instance. It is also published in the scientific literature, the Journal of Electromagnetic Biology and Medicine. And I think there are also other experiments, at least indirectly, indicating that our cells are coordinated in long-range mode, not only short-range, as biochemistry would say. It's like, for instance, agglomeration or erythrocytes. That is some very interesting phenomenon that can be seen. And there are also, I think, some experiments that show this coordination of cells and even brain, long-range coordination.
That brings us to that brings us right to the brain, which is what we were going to talk about next, and how Bion actually made that transition. I know you do a lot of basic biological research in this area, but at some point it seems that research was being done on the brain and resulted in the NeoRhythm device.
Yes. So as I told you, we began with plants, and we did many research on plants, but we also studied, theoretically, this field, which is very important, of course. So to also understand what's going on, how to explain certain phenomena. And it was some, let's say, 7 or 8 years ago that we were invited to make a clinical evaluation of certain medical devices that work on electromagnetic stimulation, magnetic stimulation actually, on human bodies, not only in brain, but on all parts of the body. And we did this clinical evaluation. There was even, let's say, evaluation of our evaluation by certain high expert European Commission, and we passed this examination successfully. And at the same time, we made an extensive study of scientific articles in bioelectromagnetics. We also have our own research published, as I told you. And there were also some successful doctorates, because I'm also a professor at our university. I used to lecture bioelectromagnetics, and there were certain young researchers that successfully finished their doctorates in bioelectromagnetics with me, but also mainly on plants. But because of this successful clinical evaluation, we met some few years ago the group of Marco, and he had at that time some experiences with devices for bioelectromagnetic simulation, and how to produce such devices, how to sell such devices too. So that we met, and we saw that we can unite our knowledge, our experiences with high synergy. So we began to work together, and we began to work on the NeoRhythm device. Our work was, in a way, of course, divided. The group around Marco worked more on this building of the device, generating, composing the device that it is suitable, to wear and so on. But the Bion group, actually, because we were more on the scientific side, we made an expertise into stimulation fields that prove themselves to be the most effective in stimulation certain states of brains, and that all of them was on this low level rTMS, stimulation regime. So not forceful, but of low intensity, which is very interesting and fascinating. I can only say that there is, for instance, as far as I found, only one study for sleeping, for instance, that was clinically based. This was a clinical trial, with placebo control, randomized and so on, performed by German scientist Pelka. It was published in 2001, so it's almost 20 years old, but on quite a large group of people, around 100, and it was found that even stimulation regime of 4 hertz, which corresponds to just a border between delta and theta waves, was very effective to induce sleep or to improve sleeping through the night, even if the, let's say, the intensities were so small that by ordinary science they would be negligible. Like approaching 1 nanotesla, it is really amazing. So when we saw this study, and of course we know also many other studies, but this is an example because it's the only one involving sleeping, up to now. We are now intent to perform, 2 more, but it's another story. So encouraged by this, we actually decided to do this NeoRhythm device with, let's say, 7 or 8 programs that would be all low intensity level, but still based on literature and let's say on intensities that were still much higher than this nanotesla that I mentioned before, but still much lower than high intensity rTMS.
So the high intensity rTMS, I think, is easier for people to visualize. Here comes the magnetic field. It depolarizes the neurons and they fire. Yeah. And you were saying in your paper,
you would think that there would be a resonance effect where you could fire at something like 8 hertz on the magnet, get the neurons to fire at 8 hertz, and then boom, you have an alpha state in the brain. But this is more complicated. And I was hoping you'd be able to go into, and you talked about this in your paper a little bit, about what is actually being affected from a smaller magnetic field with Tesla strengths that are, it looked like maybe 1/100th of the strength of a high intensity TMS.
Yeah. Mm-hmm.
And you even touched on, it might even have to do with the bioelectric stability of the membranes of the neurons or something like that. Would you be able to dive into that further? I found it really interesting in your paper when I was reading about it.
Okay. So we made 2 researches. One in, let's say, enhancing that one is more wakefulness or so, and another enhancing relaxation. So these were 2 different frequency regimes, and also 2 different, quite different separated researches. Now, what we followed in both of them is, of course, that it was a sort of a clinical trial, so placebo control or randomization, so that really nobody, even the assistant of the research, knew when the volunteer was simulated and so on. And then there were measurements, physiological measurements of these brain waves, and also of other physiological parameters like heartbeat or heart rhythm, respiratory rhythm, then temperature, and breathing, So, and there was also a questionnaire that they were had to fulfill before and after each of these, let's say, examinations or testing. And with both researches, we made 3, let's say, tests. One was the test of a device that did not work, let's say sham exposure to this. Yeah. Then the device was on with a stimulation regime as it is used now in NeoRhythm device, And then there was a third interesting group that was informed that the device is on, so that we can see what is the addition of this placebo to the effective, electromagnetic effectiveness of this device. And there was quite an interesting results. If you think we can go through, or I just will resume some of them. So our expectation was, because we read a lot of literature concerning such stimulation, that there should come to the entrainment, which means some resonant effects between this incidental magnetic field that stimulated, it was a stimulating regime of, let's say, alpha waves, so that it would induce alpha waves in our brains, not working on firing of neurons, not even working on biochemical reactions at synapses, but through working on this electromagnetic field of the brain as a whole, in a way, so that to resonantly, to come to this resonance. But if we are with the resonance, it is not a simple thing, because the literature also shows that we can count also on subharmonics of our main frequency, which means if we use, let's say, 8 hertz, even some oscillation at 4 hertz or 2 hertz can be stimulated, so this is subharmonics, or higher harmonics. So if we again use 8 hertz, 16 hertz, or 24 hertz or something in between can be also stimulated. This means that you cannot be wise in advance. You should do the experiment using such and such stimulation regime and see what really are the effects, because they can be different from expectations. There are researches published which proved that volunteers in certain regimes can be sensitive to higher harmonics, which means that you can stimulate them with, let's say, alpha waves, but they can react as if the beta waves were stimulated, so because they are of higher frequency. Well, in our research, we can say that with stimulation of this higher attention, you know, so in higher wakefulness, we did this experiment using a special clock exercise that the volunteers had to perform during the testing, you know. So this half an hour of test duration, they had to do a very intensive task, you know, of a certain something that is called clock test. I will not go into detail here. Everybody can read it in our article. It is published and open. But what was here interesting is that you know, this test used all their attentive capacities. And what we found was that with stimulation of beta waves, you know, we did not provoke more stimulation because they were already on the highest level, which was very well seen when we compared these beta waves, intensity of beta waves at this experiment with the experiments of relaxation research, you know, where these beta waves were on much lower level, actually. So even the control group, you know, here with the attention experiment was at the extreme level. And what we found here, for instance, what we could not say that attention as such was stimulated, because it seemed that its clock tests actually already provoked all their attention, but this magnetic stimulation caused that they were more relaxed. But this means that there was less fatigue in them, you know. Actually, the group that was exposed only to the magnetic field and that was not informed, so not placebo group, you know, placebo plus magnetic field stimulation, not that group, but only magnetic field stimulation that was not aware if it is stimulated or not, reacted in the sense of much higher relaxation after that. It is seen by their responses, you know, afterwards, and also by our measurements of physiological parameters like electric skin conductance, you know, that dropped much more in this experiment than with the sham exposure or non-exposure. I think that these were actually unexpected but important results that showed that the device itself has an objective effect on human physiology and on brain waves, you know. And it was something similar with tests on relaxation, you know. There also was a drop of this electric skin conductance or heart rate, for instance, in this research.
And is this how the company determined settings for the device? You systematically went through different tests in order to determine this is the frequency that we're going to use for calm, this is what we're going to use for attention?
Yeah. I mean, this was only, we performed the research for these two regimes, you know. So for attention or enhancement wakeful state, and for relaxation. For other, you know, we made an expertise for all these stimulation regimes that are actualized in NeoRhythm device, you know, like certain programs. And so we did these two researches. For other, this expertise was used, and now we do the questionnaire to see the results of many users, you know, many thousand users, how really they experienced also other stimulations. And we are just preparing now the follow-up for the attention and relaxation research, this physiological and psychological research. And we intend to do two different researches, one preparatory through questionnaire for all these users that already use NeoRhythm device, and one that will follow later, and that we will do with physiological measurements that will be controlled also, and through questionnaires actually, yeah, with questionnaires that will be, it will last for 2 months, you know, with VAS questionnaires and other forms. And it will be a blinded test, so they will not know under which regime they are. And we will, through this, test different stimulation combinations, like different combination of frequencies. We use this also in this NeoRhythm device, and a combination of, let's say, one frequency, or frequency regime, and intensity. Because even in this experiment, through feedbacks that we have, I mean, in this already used feedbacks from the users, you know, I use it too, you know, so in my personal life, of course. So we see that it may be even very, at least too intensive, this stimulation, even if it is, let's say, 25 millitesla, which is a low level, still very low transcranial magnetic field stimulation. But it's saying that through this accumulation, you know, because you know that when we have resonance, you know, these waves, in a way, their power accumulates. Perhaps you know that a bridge can be collapsed just by resonance.
Right.
Yeah, if let's say army is marching, rhythmically marching over the bridge, it can collapse it, you know, just by
Or wind
that.
has done that before too. Wind blowing at a certain frequency.
Yeah, if there is resonance. So this resonant effect can be quite high through time, you know, and so it seems that in certain cases it is even good or even better or the best if such device is put to the side, you know, or to the head, and so on. So this is what we will test scientifically in the future. So actually, we imagine that we will develop the NeoRhythm devices through successive, you know, scientific research.
Yeah, I was meditating with it at one point, and I got into a very deep state with it pretty quickly, and it really made me feel like there was a potentiating effect to it.
Mm-hmm.
And what I wanted to ask you was, you know, in the randomized controlled trials, you investigated the placebo effect, and I wanted to ask if there was a theoretical idea behind why it actually enhances the effect physiologically if you are trying to direct it in a certain direction using meditation or attention or relaxation. Is it the resonance that amplifies the effect that you're already working towards, or would you be able to explain that at all? Did I ask the question right?
I don't quite understand. So you are asking about placebo, or about because you used this word, or
yeah, I'm asking about placebo, and if there is an actual explanation for why the placebo works with the advice in terms of physics.
Yeah, if you come to the placebo and the physiology of placebo, there are many very interesting researches. One research shows that the placebo effect in general is increasing through time. I mean, in 100 years, for instance. Mm-hmm. And it is not important in which area. For instance, it can be something, some pills for the heart, for instance, or others. There are also known operations, you know, knee operations that were made as a placebo operation, so that there was nothing was operated actually. There's only cut, and then, you know, it was put together again. And after which, and it was known that this placebo worked almost in the same way as the actual operation. This is one part that is very, very important to ponder on, you know, and to reflect it, that actually our brain with certain, let's say, this electromagnetic state that can work on the quantum field level can have a very, very important and penetrating power on not only on biochemistry, but even on a mechanical level, perhaps, right. You know. Another important thing is that there was, you know, experiments that just try to see the placebo effect when morphine was used. And you know that there is a drug called naloxone that mm-hmm. blocks the morphine receptors so that morphine doesn't work anymore, so that the pain is still here, you know. Now, it was a shocking experiment when the placebo was used, and it worked to some measure. But when naloxone was applied to the patient, placebo worked no more. So it was found through such research that placebo at certain level must, let's say, manifest itself on the level of biochemistry, on yes. the receptors and so on. So if we come back to the placebo, so the placebo is a state of our minds, or let's say it corresponds to a certain state of our electromagnetic field in the brain, which can have a similar effect as the pills themselves. So as biochemistry, biochemical effects. It can emulate the biochemical effects, yeah?
Yeah.
And it can have a similar effect to, or additional effect to, the electromagnetic stimulation of brain or some other part of the body. Perhaps you know that there are certain cases interesting that were reported by users that they can use their NeoRythm devices also on animals for the pain treatment, you know. They were even photographed, and it was successful too. So it works actually on our endogenous electromagnetic field in the first place, I would say.
And just to be clear, I'm not saying that this device is a placebo effect, that it doesn't do anything, but what we're saying is it can amplify a state of mind through the bioelectromagnetic.
Yes, exactly. So this was the reason why in our research we were interested also in this, let's say, state that is a state of the users, because they are exposed to electromagnetic stimulation, but at the same time to the placebo, because they know they are stimulated, you know.
Right.
So this is the, let's say, real thing, yeah? Because in reality, they are not unaware if they are stimulated or not. They know they are stimulated. But we wanted to know if there is, in this, our research, if there is an objective effect, so beyond placebo, and what placebo works in addition to it. And so we found that sometimes, to our surprise, the effect of magnetic stimulation was higher than if the placebo was used, maybe because there was some expectation of the volunteers that there should be some effect that was not felt that, you know, that way. So there was some, you know, complicated psychological state that actually worked against the stimulation itself. But when they were unaware about the stimulation, it worked, you know.
Yeah.
And what we found, and we found this with also with other researchers, is that the direct magnetic stimulation, you know, can be much more detected with our reliably detected with our physiology than with our psychology. We found, for instance, that with relaxation testing, volunteers really recognized, because they were asked after all these three experiments, you know, when they considered to be really, you know, under stimulation, and more than a half, I think that around 60%, responded in a correct way, you know, 23 not, but I think that a little more than 60% responded correctly. So that even on a psychological level, they recognized when they were stimulated mostly, but not so with enhancing attachment. Attention, because in this experiment, their responses, you know, psychological afterwards, were wrong. So then mostly they thought that they were tested when they were not, you know.
But you could see the marker. You could see that. Sorry, I just cut you off. But you were about to say the markers of the actual skin conductance showed otherwise.
Yeah, the markers showed that they were more relaxed. As I told you, it was the strategy of these experiments followed this testing, you know, clock test, which means that they should have been very attentive, you know. And this situation had also its drawbacks, so that certain effects of magnetic simulation could not expose themselves, you know, could not be revealed, because actually they could not even develop in this experiment. because of this intensive work and load for the brain in this experiment. So that we tested a very, let's say, special situation. Of course, a situation when a volunteer or a human is under a very specific stress. So we can envision different future experiments that perhaps a volunteer would be not exposed to such strain, you know. And in this case, I would expect different physiological measurements. But physiological measurements in heart rate and skin conductance showed deeper relaxation when they were exposed to the magnetic field treatment.
Mm. And I think you touched on this before with the difficulties of taking a look at beta brainwaves, but is there, how did it work with EEG waves? Was there a noticeable change that you could report in the randomized control trials, or is EEG too difficult to track at this point using this technology?
Sorry to say, so if there is a, let's see, I think that it is not difficult to do the experiments and to measure the EEG waves.
A lot of my users, a lot of my viewers of the YouTube channel like to use the EEG measurement devices like Muse, Headband, as well as some others. Would you have some advice for them about how to actually take brain measurements themselves and see if there's been a change in EEG waves before and after using the device?
Yes, they can look at the brain waves before using the device, let's say, for some maybe 15 minutes or so. And then that maybe, I don't know if they can detect this brainwaves intensities during the device's work.
I don't think so. I think the magnetic wave would probably interfere with the signal, right?
Yeah, we found that they did not interfere actually. we could measure. We could measure them, during the testing, all this half an hour. But we had to, experiment with this before, so that we knew how to do it during the experiment. But maybe they could do this too, and I would advise them to do this also afterwards. So after they expose themselves to the NeoRhythm device, either for meditation or for relaxation, or even for nap, sleep, which is short, so that they could see this. Because in our experiments, but because they were exposed to this stressful situation, we found, for instance, that alpha waves were growing, through this working of the device, which again was in harmony with skin conductance and heart rate, so that they were more relaxed at the end, which means that in a way they perhaps used not so much energy as if they were not exposed to the magnetic field stimulation.
Do you have any advice for using the device for meditative practices? Anything that people have found works best?
For medical?
For meditation.
For meditation. Well, I think that both these stimulations would work. Maybe they should put it some 5 to 10 minutes even before going to meditate, so that this effect accumulates just before they go to meditation. So I would advise them to, of course, not to do something stressful and hard, but let's say prepare for meditation, perhaps drink some water or just look through the window before meditating, and already use the device some, as I told you, 5 to 10 minutes before start of meditation.
Sounds great. I know a lot of people are going to be really excited to take a look at brain waves and try to meditate with it, but then also use the other settings as well. And I really appreciate you coming on and talking about the actual science behind it, the experiments that have been done with the technology, and really appreciate your expertise, Dr. Jerman. So thanks for coming on.
Yeah, thank you too for this interesting discussion.